In this tutorial, we'll show you how to set up our BACnet router in a BACnet network. To do so, we are going to use the IntesisBox IBOX-BAC-ROUTER and the IntesisBox MAPS software. To show you how the BACnet router works, we will use one of our air conditioning gateways connected in a BACnet MSTP network, and we will use the router to integrate it in a BACnet IP network. Okay, let's begin opening IntesisBox MAPS software. Now we will click on Create New Project. To see all BACnet templates available, we will click on the BACnet logo. And then we will choose the template for the IBOX-BAC-ROUTER. Finally, we will click on the Next button. Once the project is opened, let's move to Connection tab. You could skip this section if you don't have the gateway with you or if you simply want to work with the project offline. But now we are going to explain you how to connect to the gateway. On Connection tab, we have two connection options, IP and USB. In this demo, we are going to use the IP option, because BACnet router doesn't have USB port. So we will click on IP port, and then we can choose introducing IP address and communication port of BACnet router. By default, IP is 192.168.100.246 and communication port is 23. Otherwise, we can choose our device from discovered gateways list. If we can't see the router, click on the refresh button to discover it. After pressing the button, if not appearing on the list, check that connection with the device is correct. Now, on the right side will appear all information of the selected gateway. And finally, if we are working with a new gateway with factory settings, we don't have to use any password, as from factory, the gateway comes without it. But if we are going to connect to a gateway that already has been set up, you will have to provide its password here, and then click on the Connect button. So now we are connected to gateway, as we can see in the status bar at the bottom. Now let's begin with the configuration by clicking on the Configuration tab. In General Settings, we can set a name and description for this project. Then, on Connection section, we can enable or disable the DHCP option. With factory settings, after powering up the gateway, DHCP will be enabled for 30 seconds. After that time, if no IP is provided by the DHCP server, the default IP will be set. If the gateway has been already configured, DHCP will be enabled or disabled based on your configuration. In this demo, we will use a fixed IP. So let's disable DHCP option, set the IP, mask, and the default gateway if it's needed. Finally, we must choose a password for this project to protect IP connections. In this case, will be demo. On the BACnet server settings, we can change a few options for BACnet IP and MSTP networks. In general configuration, we can set the device name, which is the name we will see from BACnet Network. And in this case, we will leave the default value. In the device instance field, we will set the instance number. By default is 246 in all IntesisBox BACnet devices. In this case, in order to avoid any problems with other devices in the network, we will change the default value. Finally, password field is a password for BACnet protocol, used to protect some BACnet operations. On BACnet IP network configuration, we can modify UDP port used for BACnet communications, and we can configure the gateway as a BBND, useful when there are IP routers between devices on the same network. To use this feature, we must configure IP addresses and port numbers of BBMD devices on the network and activate Enable checkbox. Finally, we will set the network number for the BACnet IP. This number must be unique in all BACnet network. On the BACnet MSTP network, we can configure the baud rate of the MSTP line. By default, is set to auto, meaning that the device will read the configuration from the MSTP line. Note that this feature needs at least one device configured to establish the baud rate of the line. The next parameter is max masters. This is the highest master MSTP node number used on the bus. Consider this parameter to optimize MSTP communications. An adjustment far above the real masters connected could lead to a slower network due to the lost time while pulling the masters that are not present. In BACnet standard of MSTP, a master device could hold a token until it has sent frames up to max info frames parameter. The default value is 10, but for the router, this value may be increased to improve bandwidth between networks. This value should be high enough to allow the transmission of at least as many MSTP frame packets as there are available in the buffers. Normally, the suggested value is between 5 and 20. The MSTP MAC address of BACnet router selected must be different from any other MSTP device on the same network. Practice dictates that routers should be assigned MAC address 0. Now, let's finish the configuration, setting the network number for the BACnet MSTP network. This number must be unique in all BACnet network. Finally, we will use BACnet Explorer utility to see all connected devices on IP and MSTP networks. When we open BACnet Explorer, it starts exploring automatically, and it shows us devices as it finds them. By default, exploring process never ends. To stop it, we must click on the Stop button. If we want to see information about some device, we select the device on the BACnet Devices tree, and then its name will be shown. To see the device objects, we must click on the Discover Objects button. This process can take several minutes, depending on the number of BACnet objects the device has. When the process finishes, we can see all BACnet objects available for this device. On the advanced configuration, we can set up some parameters to adjust the exploring process to our requirements. The start and end instance parameters will help us limiting the search to a specific range. Also, we can activate Discover MSTP Slaves checkbox to search MSTP passive devices by setting the range of MACs to explore. When the setting is done, we must click on Apply button and changes will apply to the current exploring. Now we will close the BACnet Explorer and let's move to the Signals tab. Since we are working with a router, we can add, remove or edit signals. However, IBOX-BAC-ROUTER includes some signals for diagnostics purpose. We will see all of them in detail on the Diagnostic tab. Now let's click on the Receive and Send tab. If we click on Send, the gateway's configuration will be sent to our gateway. When the process is done, a message will appear. Then the gateway will reboot and maps will be disconnected. From this tab, we can also receive a project from the gateway, in case we want to have the actual project working in the gateway. Now, let's click on the Diagnostic tab to check that all the setup we have done is working properly. Once the gateway has restarted, we can reconnect by clicking on the button located at the bottom. Here we can see 4 different viewers: Console, BACnet IP Viewer, BACnet MSTP Viewer, and Signals Viewer. On the console viewer, we can see general information about the gateway. Also, allows us to send 2 different commands to reset the router or to get information about it. On the BACnet IP and MSTP viewers, we can see in real time all communication frames in their respective networks. On these viewers, by default, we can see the spontaneous communications, that is, all changes related to their internal signals. In this case, as we only have the statistic signals, we only see a spontaneous message related to these signals. These viewers also allow us to see raw communication frames on the network by enabling comms checkbox and also see some debug message enabling debug checkbox. Another useful utility we have in the IntesisBox MAPS is the ability to filter online messages in the viewers. The filters can search a specific string or text based on irregular expressions. Finally, we can configure the visualization choosing to show only messages with a specific string or show all messages, highlighting those that contain the desired text. For example, we can configure a filter to view only changes related to signal 6. So we must search a string 0006 and choose the visualization method desired. Then we must enable the filter to apply it. The last viewer is the Signals viewer. It shows us all internal signals and their values in real time. The last step is the checking of that system is working properly. For that, we will use Java, an open source BACnet Explorer, to explore BACnet Network and view devices connected in the MSTP network. First, we must add a new communication port. Once created, in the devices tree will appear the router. Then, to see all devices on the MSTP network of the router, we will have to expand the router device. Under it, we will see all devices connected to their MSTP network. In that case, we only see the AC gateway, as it is the only one connected to our network. Now, let's select the AC gateway to see all signals available. After that, we will select all signals and subscribe for all BACnet objects to see the object values. On the other side, we will use an air conditioning simulator, and we will see how values change on BACnet and on AC simulator. Now, let's begin with room temperature. We will change room temperature on AC simulator, and we will see how it changes on BACnet Explorer. Also, we will do the same with on-off command, turning on the AC unit. Now we will change the temperature set point from the BACnet side, and we will see this change in the AC simulator. And finally, we will do the same with AC mode. So that's it. I hope you like it, and see you in the next tutorial.